Hello dear students, this is your Engineering Mathematics 3 lecture. Today's topic is regression lines. Actually, we have started this topic in previous lecture. Now here, we are going to discuss one example on regression lines. This topic regression line is from third unit statistics. Now see the example. Two variables x and y have regression lines. 3x plus 2y minus 26 is equal to 0 and 6x plus y minus 31 is equal to 0. Then find the mean values of x and y, and second, correlation coefficient between x and y. See, here the regression lines for x and y variables are given, and we have to calculate the mean values of x and y. Means you calculate x bar and y bar, and then you find the correlation coefficient of correlation between x and y. See how to calculate the mean values and coefficient of correlation from regression lines. In previous lecture, we have discussed the example where we have find the regression lines from the given data. Now here the case is reverse. The regression lines are given and we have to calculate the coefficient of correlation. See how to find. Let x bar, y bar, the order pair x bar, y bar be the mean of regression series of x and y. See, x bar is the mean of x and y bar is the mean of y. So it is the order pair x bar, y bar, it is the mean of regression series of x and y. So if x and y are satisfying the equations, regression lines, then obviously x bar and y bar satisfies equation of lines of regressions. It is obvious. If x and y are satisfying, then the averages of x and y, this x bar, y bar will satisfy that equations of regression lines. So we can replace x and y by x bar and y bar, both the regression lines. 3x bar plus 2y bar minus 26 is equal to 0, means 3x bar plus 2y bar is equal to 26. Second equation, 6x bar plus y bar minus 31 is equal to 0, means 6x bar plus y bar is equal to 31. Now we'll solve these two equations. To solve these two equations, now we are going to remove the variable y. We have to remove y, then you multiply this second equation by 2, so that we will get the new equation 12x bar plus 2y bar is equal to 62. 31 into 2, 62. Now solving the equation number 1 and equation 2, means subtract equation 2 from 1. See, the subtraction is here. 3x bar plus 2y bar is equal to 26 minus 12x bar plus 2y bar is equal to 62. Now this is a subtraction, so you change the sign of every term. Change the sign of second equation. 3x bar minus 12x bar, 9x bar. 2y bar minus 2y bar, it's 0. It is equal to 26 minus 62 minus 36. And so x bar is equal to, you shift this minus 9 here in RHS, it will be in division, minus 36 upon minus 9. The calculation is x bar is equal to 4. X bar is equal to 4, so you put in the either equation. X bar is equal to 4, suppose here in second equation, x bar is 4. So 6 into 4, 24. 24, you shift that 24 here in RHS, so y bar is equal to 7. So these are the means, x bar is 4 and y bar is equal to 7. So first aim is here, we have to find the mean values, of x and y. So the mean values of x and y are here, 4 and 7 respectively. Second is, you find the correlation coefficient. To find the correlation coefficient, you first find the regression coefficients of y on x and regression coefficient x on y. Now two regression lines are given. So you assume either equation regression line of x on y and the second one y on x. You can assume anyone. Assume the first equation, assume first equation as regression line of y on x. 3x plus 2y minus 26 is regression line of y on x. So it is the regression line of y on x. It is our assumption. You assume it. Now your question will be here, why we are assuming the first equation as regression line of y on x? then the answer is here that you assume any equation as a regression line of y on x and any equation y x on y. But in final answer, when we calculate the coefficient of correlation, then that answer must be less than 1, because we know that coefficient of correlation, its value is always less than 1. If you are getting it greater than 1, then in that case your assumption is wrong and you interchange the equations in that case. That is the solution. So here this is only our assumption that first equation is 3x plus 2y minus 26. This is the first regression line, and we are assuming it is the regression line of y on x. It is the regression line of y on x, so you find the value of y. So 2y is equal to, rearrange the equation, 26 minus 3x. So 2y is equal to, write the term of x first, minus 3x plus 26. And so y is equal to minus 3 by 2 into x plus 13. So this is the value of y. We assume it the regression line of y on x, so you find the value of y. And so the term with x is nothing but the regression coefficient. You always remember that when there is a regression line of y on x, in that case, the coefficient of x is nothing but the regression coefficient of y on x. Means it is the value of byx. So it is equal to minus 3 by 2. Okay. Now, assume the second equation 6x plus y minus 31 is equal to 0 is the regression line of x on y. This is also our assumption. Now, we are assuming that it is the regression line of x on y. So you find the value of x. So the value of x is, rearranging the equation, we have the value of 6x, it is equal to 31 minus y. Then you rearrange it again. And so x is equal to, you divide the equation throughout by 6. So it is minus 1 by 6 into y plus 31 by 6. So I assume that this is the regression line of x on y. So the coefficient of y is nothing but your bxy. You always remember, when we assume the regression line of x on y, then in that case, the coefficient of y is nothing but your bxy. You remember it. And so this is the regression coefficient of x on y, bxy. Now, the formula to find the coefficient of correlation is given as r is equal to under root bxy into byx. Actually, we have discussed it in previous lecture, the regression lines and the formula to find the coefficient of correlation. So this is the standard formula to find the coefficient of correlation from the regression coefficients. So put here the value of bxy and byx. And after putting the values, you do the calculation, and the calculated value is 1 by 2. 1 by 2 means 0.5. So our coefficient of correlation is 0.5, means it is the correct value because it is less than 1. So our assumption here is correct. That first equation we assume that it is y on x and second as x on y. If here your answer is r is equal to, means coefficient of correlation is greater than 1, then in that case your assumption is wrong. Then here you have to interchange the equation, means you, then in that case you consider the first equation as regression line of x on y and second as y on x. This is the solution in that case. But here the value is r is equal to 0.5 is less than 1, so our assumption is correct. So this is the way to find the coefficient of correlation. There is one more example, you try yourself, try to find the solution. If two lines of regression are here, 9x plus y minus lambda is equal to 0 and 4x plus y is equal to mu, and the means of x and y are here 2 and minus 3 respectively, then find the values of lambda, mu, and the coefficient of correlation between x and y. So here two regression lines are given. Again, the means of x and y are given 2 and minus 3, means x bar is equal to 2, y bar is equal to minus 3. Then you find the value of mu and lambda. So how to find these values mu and lambda? Then in that case, you, if x and y are satisfying these equations, then order pair x bar y bar also satisfies these equations. So you replace x and y by x bar and y bar in these two equations, like the previous example. And then solving these two equations, there you put x bar and y bar. You know x bar is 2 and y bar is minus 3. Put in every equation. Then you will get lambda and mu. After finding the values of lambda and mu, you put here in these two equations the values of lambda and mu. And then there will be two regression lines with the constant terms, and then like the previous example, you find the coefficient of correlation. Means you first assume first equation as a regression line of y on x, second x on y, or vice versa. Condition is only that in last your coefficient of correlation must be less than 1. If it is greater than 1, then you interchange the equations. Means if we have considered first y on x, first equation as a regression line of y on x, second x on y, and your coefficient of correlation is greater than 1, then in that case you interchange. Means you consider the first equation as a regression line of x on y and second y on x, and then you calculate the coefficient of correlation. That is the solution only. So these are the examples on regression lines. Try to solve this homework example. Here you remember that when we consider regression line of y on x, then in that case we find the value of y, and when we find the value of y, the coefficient of x is nothing but your byx, regression coefficient y on x. And when we find the regression, we assume the regression line of x on y, then in that case we find the value of x. And when we find the value of x, then in that case the coefficient of y, the term constant value with y, is nothing but your regression coefficient x on y, means bxy. And bxy into byx, you do the multiplication and then you take the square root. That will be your coefficient of correlation. Okay. So these are the examples on regression lines, and this topic regression line is over here. And today's session is also over here. Thank you.